Okay, now we're going to talk about graphs of functions. So, any function f of x can be represented visually using a graph. Now, what do I mean by that? Well, we'll have two number lines. One will be called the x-axis, that's going this way, and on the x-axis, we'll have the inputs to our function. There'll be another number line going vertically called the y-axis. This will have the outputs of our function. Now remember, for each input, there is exactly one output. So think of it this way. We move right or left along the x-axis, and that's us changing our inputs. And what the graph tells us is how the outputs look as we change our inputs. So let's move up here to a very simple function, f of x equals x. Okay. Here we have the x-axis, which has our inputs. Here are some examples of inputs. 1, 2, 3. And f of 1 is equal to 1. Right? If we plug 1 into the function f, then what it outputs is 1. Right? Because here we've made x equal to 1, and so on the other side we simply have 1 again. And now this equation here, f of 1 equals 1, corresponds to a point on the graph where our input is 1 and our output is also 1. Now here we have another example, f of 2 equals 2, right? Because if we plug 2 into this function, then what it spits out is 2. So here again our input is 2 and our output is 2. So on the graph we move along. Here's our inputs. Our input is 2 and our output at that point is also 2. Okay. A slightly more complicated function is g of x equals x squared. Here, for example, we can input -1, and what this function will spit out is +1, because if we take x and we make it -1, what we get here is g of -1 equals -1 squared. Right? Here the negative sign is inside the parentheses. So we get 1. And now we can see this on our graph. If we go to where our input is -1, so right here, then our output at that point will also be 1. And here's another example. G of 2 is equal to 4. When we plug 2 into this function, what it does is it squares it, so we get 4. And so if we move along our inputs to 2, we see that the height at that point is 4. So this is how we graph a function. Now, I've only really shown you how to graph a single point. I haven't explained to you how I figured out what should happen in between the points that I graphed. For example, we know that g of -1 is 1, and we know that g of 2 is 4, but the way that I've connected them is very suggestive. Right? Why wouldn't I just jump, say, straight up to here by drawing a straight line across? Well, the answer is that's not what this function actually tells you to do. The graph of x squared is actually this kind of U-shape parabola. So it's actually only in calculus where you really understand how to figure out the shape of a graph from its equation. So for now, the best way to figure out the shape of a graph is to plot a bunch of points and sort of see how it looks and then connect them in the appropriate way. So here, for example, I plotted these points. I plotted 1, 1, 2, 2. Here's 3, 3. Actually, let me write that down here. The way that you write a point on a graph is as the input, comma, the output. So down here, for example, we would write this as -1, 1, because here our input is -1 and our output is 1. Okay? So I plotted these points, and then I extrapolated, and I said, okay, it's probably the graph of a line, so I connected them with a line. Down here I did a similar thing. I only graphed these 5 points, but I know that the graph has to be a U-shape. Well, I guess I don't know that simply from the points, but I try to connect them in the nicest way, and this is how it comes out. Again, it's only in calculus that you really figure out and understand how the graph of a function comes from the equation. So for now, we just plot some points and we connect them in the best way we can.